In Lesson 2 of Section 2 in Unit 6, we will continue our look at the preservation of equality with multiplication in Video 1 and division in Video 2. In this video, we use our two-pan balance and algebra tiles to demonstrate how equality can be preserved using multiplication. In our consideration of multiplication, first we'll look at our balance scales. And this time we need to be thinking, whatever I multiply one side of the equation by, I must multiply the other. We will only multiply by natural numbers that are greater than 1. Numbers such as 2, 3, 4, and so on. If you think about it, multiplying by 1 does not change anything. Here, once again, is our two-pan balance. Let's add some masses. So on the left-hand side, we've put a mass of 5, a mass of 3, and a mass of 1, giving us a total of 9. On the right-hand side, we've added a mass of 7 and a mass of 2. Once again, if we total that up, we get 9. 9 on both sides. Obviously, our pan is balanced. So 5 plus 3 plus 1 equals 7 plus 2. What if we now decide to triple everything on the left-hand side? So instead of one mass of 5, I have 3 masses of 5, 3 masses of 3, and 3 masses of 1. Well, no longer will our two-pan balance be balanced because we have much more on the left-hand side. I have tripled everything on the left. In order to maintain balance, what would I need to do? I would need to triple everything on the right-hand side. So 3 masses of 7, 3 masses of 2. We have multiplied both sides by 3, or tripled what we have on both sides to maintain balance. In our second example, we'll look at a linear equation. So we have m plus 2 equals 4. I'm using my hexagon again for my variable. So I have 1m. Remember again, there's a 1 understood to be in front of that m. A mass of 2 on the left-hand side. And then on the right-hand side, we have our mass of 4. So we have it represented. So what if we multiply one side of our equation by 4? If I take the left-hand side and make everything 4 times as big, I end up with 4 hexagons for 4m, and I end up with 4 masses of 2. To maintain balance, we must multiply the other side of the equation by 4. In other words, we are quadrupling everything on both sides. So instead of 1 mass of 4 on the right-hand side, now I have 4 masses of 4. Once we put in those 4 masses of 4, we get our balance back. And our equivalent equation, well, if I count up the hexagons, I have 4 of those, so that's 4m. 4 masses of 2 will give me 8, and 4 masses of 4 will give me 16. So the equivalent equation becomes 4m plus 8 equals 16. As mentioned in the previous video, we are not solving the equations here. We're just creating equivalent equations. If we decided to solve m plus 2 equals 4, and if we decided to solve 4m plus 8 equals 16, we would get the same solution because they are equivalent. Let's consider now our second model, the algebra tiles. Whatever I multiply one side of the equation by, I must multiply the other. Here's a linear equation, 3n equals 6. And our first step will be to represent. So for 3n, I have 3 variable tiles. And for the 6 on the right-hand side, I have 6 units. So my left-hand side, 3 variables. My right-hand side, 6 units. Left-hand side, right-hand side. What will we multiply by this time? Here we're going to write an equivalent equation by multiplying both sides of the equation by 2. In other words, we're doubling everything up. So if I have 3 n's and I double them up, I should get 6 n's. If I have 6 unit tiles on the right-hand side and I double those up, I should get 12. And there they are. We have our 6 variable tiles on the left-hand side and our 12 unit tiles on the right-hand side. Everything has been doubled. Our equivalent equation, if we write it symbolically, then will be 6n equals 12. One more example. 3 equals 2n plus 1. We'll represent first. So we see on our left-hand side, we have 3 units. On our right-hand side, we have 2 variables and our 1 unit. What are we going to do to both sides here? We are going to write an equivalent equation by multiplying both sides of the equation by 5. And you should take note here, as we increase that factor that we're multiplying by, when we're using a model, that just means we have to draw out that much more. But that's okay. We're just getting a visual here as to what this process is all about. So if we go back to our original equation, 3 equals 2n plus 1, well, for the left-hand side, I'm going to need 5 groups of 3. And on the right-hand side, I'm going to need 5 groups of 2n and 5 groups of 1. And when I put all that down, these are the algebra tiles I need to represent the situation. Now on the left-hand side, 5 groups of 3 units will give me 15 units. 5 groups of 2n will give me 10n. And 5 groups of 1 will give me 5. Symbolically, this gives us 15 equals 10n plus 5. This is our equivalent equation. A very important idea to take away from this video is that when we use multiplication to preserve equality, we have to multiply everything by a certain factor. Whether that's 2 or 3 or 4 or 5, everything has to be multiplied. Everything has to be either doubled or tripled or quadrupled, as determined by the factor you're using. Please keep that in mind. And now I'd like you to proceed to the next video in this lesson.